Yeah, dear ladies and gentlemen, my name is Sebastian from Klinski. I'm the Vice President for Research, and I'm very happy to welcome you here at the Wherecamp and also at the Beuth University of Applied Sciences here at the Beuth Hall. I have the pleasure to do this opening here at the Wherecamp for the fourth time now. And every time I see more participants, more company representatives, and also the range of topics addressed here at the conference increases every year. And every year, the list of persons that have major influence on the location-based application industry gets longer. This year, I'm happy to welcome Mr. Christof Hellmis, Vice President of HERE. I just saw him here somewhere, here. At Parsons, Geospatial Technologist of Google. Philipp Kandal, founder of Navigon and Skobbler. And Steve Coast, founder of OpenStreeMap. Your presence here underlines the relevance of this conference here at the Beuth University, but also the relevance of application-based navigation on its own. There was a major message in the international news several weeks ago, I guess you saw it, everybody, that stated that BMW, Daimler, and VW took over HERE. This takeover by the leading car manufacturer was described as a strategic investment for supporting their autonomous car initiatives. It was also stated that these initiatives are so vital for the manufacturers that they don't want to depend on a third party like Google. This news about this takeover illustrated several interesting developments. Firstly, you see today a convergence of industries that had been widely apart in the past. Car production and location-aware IT system development. This development started with the integration of navigation systems into cars and will lead to, in the next decades, to autonomous cars all over the world, where navigation and cars will be one and the same. And this convergence of technologies will be accompanied also by a convergence of the markets itself. And accordingly, Google is already today entering the market of car production with its Google cars. And at the same time, car manufacturers will automatically also enter the market of IT services. This diffusion of location-based technologies into other markets like cars has already taken place in many other areas of our daily life. Be it autonomous vacuum cleaning robots, be it location-aware applications, or our smartphones. All these are devices that are today location-aware, and they are part of our daily life. Just as IT diffused in almost every area of our daily life, also location-based services and application will follow in almost any domain. I'm not as sure whether location services will diffuse into every device in my home. For example, I don't know whether my refrigerator or my washing machine must be aware of its surroundings, but who knows? In the future, there will be many applications that we couldn't imagine today. In any case, the ongoing developments are extremely exciting, and it's fun to exchange new ideas and concepts with others and to share them with people who have the same enthusiasm in this topic. And events like the Wherecamp are an exciting platform to exchange these ideas and find new partners to implement also these ideas. Therefore, when I skip to the agenda of this conference, I see many topics that for me as an IT professor are extremely exciting. Indoor navigation, augmented realities, geospatial, big data, smart parking. These are just some of these very exciting presentations that you can enjoy today. Therefore, I don't want to keep you longer from these interesting talks, and I quit my speech by wishing you a nice stay here in Berlin, in our university, and I wish you interesting discussions and exciting exchange of new ideas. Thank you for your attention.
Thanks very much, Mr. Vice President von Klinski. He really followed us now 4 times and really could see all the developments now My name is Roland Wagner. I'm also welcome you very much, but also, as we said already, we welcome you now for a little panel route or a panel time with what I thought GeoIT originals. That's what I think. So really people who have moved these ideas forward. And that's why I like to welcome at Parsons. Good morning. Come on. Christof Hellmis is the next one. Steve Coast. And Philipp Kandal. Please take a seat. So, that's good. That's very fine. It's anyway. I'm not sure really if I should take this seat, but somehow they brought this. Nevertheless, I'm very happy that you all made it really from far away. We were not so sure about the Lufthansa strike things, if we could really make it this time. But anyway, it's not so far from the other side, from Berlin. It's just 2 streets away. Some others really traveling the world now from Shanghai on the way to Silicon Valley with a stop in Berlin. But also at Parsons all over from London, but also, of course, more or less, that's why connected to the world. And I think it's a very good opportunity. I thought about what could be, let's say, good questions or good topics. In general, I think it's, let's say, on the one hand side, good, because if we are here in University, and you said this morning, well, that reminds me of my time at University when I came in. So one of the questions at the beginning could be, let's say, a bit like looking back, how did you manage this what you have achieved from the beginning? And I'm very sure at the beginning it was not very easy, and things were, maybe today is, again, not easy, but at the beginning sometimes it's maybe more difficult. So what were, let's say, things, what you, how you started this thing, and then later I would like to ask you a bit as well to look forward, what you see now in development of future. But let's say these are, let's say, the major, the both sides looking back a bit, and maybe later looking forward. But you're very free. So let's start, I think, with Philipp now. The first time, if you think back on the starting one, how did you really start in this industry? Because you started quite early, also in the 90s, where a lot of these ideas, Mr. von Klinski just said, were even very uncertain, and suddenly things expanded dramatically and very useful later.
Yeah, I mean, I think the beginnings were really like, the big challenge was that you couldn't like develop anything and deploy it anywhere, right? So I think nowadays when you look at like iPhones and everything, with like all these amazing sensors that we need, a GPS sensor, accelerometer and everything, and you think like at the hardest part at the very, very beginning when we started to do mobile phone navigation, it was that first of all mobile phones didn't have GPS or any other sense of location technology. The mobile phones didn't have like a proper app store that you could deploy an application to. So I think that was like the big struggles at the beginning. Actually, we didn't really struggle that much with the geotechnologies as such. We just struggled that whatever you build, you can't deploy it anywhere. So I think this was really like for us back then when I co-founded Skobbler as a navigation company with a focus on smartphones in 2008. That was really like the first time when you could see really that you could deploy this stuff somewhere, because before you could build it, right? I mean, navigation systems and all these geotechnologies were around for a long, long time. GPS was around for a long, long time. But then really was really that you could put this stuff to the consumer. And I think this is like was the biggest struggle in the beginning, that you really need to see that whatever you can develop can put to somewhere. And I think this was like the big wave when you had like the iPhones with GPS and so on. So that was what I was seeing back then, which was really amazing, which is giving like the last 10 years our whole industry an unbelievable boost, and like has sparked like applications like, I mean, it was two different waves, right? The first wave was really like navigation apps that were like are now ubiquitous, and now it's services like Uber and so on who rely on navigation technologies at their core, otherwise they wouldn't be possible. And I think now we're seeing the big third wave coming. So after we had like these two waves of technology, we were first navigation technologies and then technologies who leverage location as a key service. And now we see like another big growth of like additional sensors coming. I mean, now we see that things that used to be like in like Ed has his Google mapping cars, which cost like 80,000 euros or so just for the sensors on top of the cars. And you see now some really exciting companies in Silicon Valley who build the same sensors for like $50 a piece, like LiDAR sensors and so on. And you see that'll be probably like in a few years, it'll be $1, $2, right? So I think the really exciting stuff is what you can do with the next generation of sensors. What can you do with LiDAR? What can you do with like stereo cameras and so on? So I think that's really what I'm really excited about. And that's, I think, what in the next 5 years will bring us the next huge wave of innovation, which is like the next level of sensors being available for location.
Yeah, so Steve, how you started these developments at the beginning? It was in the UK, it was a special situation, and I think two of the actors knew each other at that time, not directly, but looking backwards was also very interesting. How did you start at OpenStreetMap?
OpenStreetMap began just as a personal project because I wanted some mapping data for myself, and I was young and naive enough to think that I could go build it. It started very, very simply. I mean, the website started as a blog, for example, and one of the main challenges was to convince people to go out and do some work for free, right? How do you convince people to go and map in the rain, in the cold, collect data for you and put it into this crazy open project for no compensation, and then build a community around it, build the infrastructure, whether that was the technology, the tooling, or the community itself, including things like starting the conference. And a lot of these things they have feedback loops between them, right? Once you get to a certain size, it's just obvious you need the next step is a conference and so on. So a lot of it was sort of very step by step, very iterative. As Philipp mentioned, the technology back then was very different. The iPhone didn't exist. You have to. I remember when you sent text messages, you had to press buttons multiple times. I know 18-year-olds now who think that's crazy. They didn't grow up with that. And clearly you grew up in the Victorian era or something when that happened. In fact, I was talking to someone recently who's 18 who told me that encyclopedia meant Wikipedia. And when I was explaining that there used to be encyclopedias that were print-bound and people would sell them, he's like, so Wikipedia had salesmen and they printed books? And it's hard to think back, but all of this has happened in the last 10 years. All of these were just ideas back then, and now it's just sort of common knowledge. It's funny, I went to the Esri user conference this year, and practically every stand was using Esri software, but OpenStreetMap data because it's free and available. So it's gone from this crazy idealistic project to part of the fabric of this industry now. And there were a lot of steps along the way, and I just wrote a book about this. You should buy my book. It's very, very good. Goes through all of the details, has an interview with Ed, amongst others. But there are a lot of different things that went into it in that way.
Thanks. And on the different side, how did you start at these developments here in Berlin, where, 10 years, I think, the wall came down. Berlin was still about 2000, I don't want to say ugly, but maybe it was not so nice. It's still maybe not so nice at other towns. But on the other, it's quite creative. So how did you start Gate 5? Or develop Gate 5?
Yeah, first I think ugliness lives in the eyes of the beholders. So there's also beautiness and ugliness, I think. So now I think a very classical path for a startup here in Berlin, founded in 1999. Very revolutionary ideas. The first products was a website. It was a combination of Foursquare, Twitter, Yelpish. User interface was ugly. It was just too much, and it didn't work, quite frankly. And over the course of the next 3 years, getting data was the problem, right? It cost money. Telatlas were the guys much more forthcoming. Navtec wouldn't even talk to us because we were too small. So you go forward, and there are these pivotal moments. And one of these pivotal moments was we showed our mapping technology at CeBIT, and a lot of Asians came and said to us, "Can your map talk?" And we were like, "What do you mean, can it talk?" And they meant navigation. So this is what brought us to develop navigation. And the other pivotal moment for me personally was driving 2004 Christmas, 600 kilometers with a Nokia device, not with a built-in GPS, Bluetooth and paired, and 2 chargers and complex, but 600 kilometers flawless navigation with 2 megabyte runtime memory. I mean, I was blown away. And this is where the moment where I thought, yeah, this is happening. It's really happening. However, I would say, and that's a bridge to the future, I think we're not there where at least our aspiration was, having always pervasive location available. You still need to power up an app. It still needs GPS. It runs only for 4 hours. It drains battery. So location has made its inroads into the DNA of modern operating systems. So none of the leading operating systems, whether it's Microsoft or Google Android or iOS, can live without location enablement inside for calendar, for camera, many, many things. But still, you have to power it up. And that's something that I think the future hopefully will solve. And we're at the advent of the sensor revolution. I think we all know that one of the biggest sensor that is in consumers' hand, the vehicle, the car, is going to be connected, and this brings huge opportunities for the whole industry to derive new capability. This is why when I ask, how do I like the word GeoIT? I don't like the word GeoIT. I don't like the word IT. I like geo a lot, but I think it's all about geo-intelligence. Because with sensor data and clever algorithms, we all derive intelligence, i.e. answers to fundamental questions. So this is why I think we're just starting. Location, to me, we were at the very early at the Stone Age. Maybe we made it to the steam engine age, and I think now we're hopefully propelling forward into the modern age where location will be a key element. Also necessary to make our life possible. With more than 50% of people living in cities, we'll have a huge challenge of organizing our life in a sustainable, safe, and enjoyable way, and that's what we all work about every day.
Yeah, thanks very much. Also, at Parsons, you had also different hats on, and you looked also on different domains. Like there was a time in Ordnance Survey, or earlier at Autodesk, very technology-driven, then Ordnance Survey. There was a time I mentioned a bit, also later on switching to Google, and I think 2005 was also a key milestone and development with Google Earth coming in. So you really had different views, and you also work in different communities, can see the different terms in a way, or different behaviors. And he gave me the important hint to go to 2012 to the Wherecamp conference, Wherecamp and the conference where there was a conference, but also the Wherecamp in Stanford. And this is where we all met far away from Berlin and Stanford. And then we said, we need to bring this to Berlin. So this was art that really gave me this point. But coming back a bit, maybe from looking backwards, really last 10, 15 years, how did you see this development?
Thanks, Roland. I'll go back even further. I think for me, it started with my first job out of university. I was a geographer by training, and like most geographers, when you finish your degree, you're left wondering what you're going to do next, because it's not obvious what your next job is going to be. But I saw an advert in the local newspaper that mentioned mapping, and I turned up for this interview, and it turned out that my first job was writing a program in Fortran to digitize paper maps of postcode boundaries that eventually would lead to all of you getting junk mail. So I apologize for that. You know, I'm partially responsible for you guys getting junk mail. But I think it was symptomatic of a time in the early part of our industry where we were very much constrained by a lack of data. And it's easy to forget today where we are swimming in huge volumes of geospatial content and mapping data, and it's not perceived to be a problem at all. Largely thanks to what OpenStreeMap did, what Google did to sort of change the business model of making data available. But in the early days, we had great technology, but it was largely empty because we didn't have the data. And I remember being at GIS shows in the 1980s, and people would rush up to your stand, and you had very shiny, very sophisticated software for displaying maps, and they'd say, "Can I see a map of my house?" And we'd have to turn around and say, "Well, no, sorry, we don't have the data for whatever your house was," because we only had a very small demo data set. Now, we all have maps of our houses. Maps are part of what we spend our days doing. Our technology has become something that is something that we all use every day, which is an incredible shift. What we do is touching almost every person who's got a phone's lives every day, and we should be proud of that we are delivering on that promise that we all saw all those years ago. So I think we've largely solved, to a certain extent, the data problem. Although I completely agree with Christof. The next challenge is to an order of magnitude increase in the detail of information that we need, particularly for urban environments, indoor mapping, mapping the environment that is just within the 10 or 15 meters around us at any point in time is going to be one of the next challenges. And I think that does lead on to where I think we probably all agree where the industry is going, and that is much more connected to sensors of various types, passive and active, and interacting with those. And that interaction coming from the network. And no one's mentioned the network, but actually we're only really sitting here, I guess, because of the internet, because of the web. because it provided a mechanism for us all to connect and to build communities like OpenStreetMap and to deliver products and services like Google Maps and Here Maps. And that network has been one of the greatest inventions, one of the greatest technological enhancements that we've had over the last 30 years. And we should make the most of that and do our best to protect it, because it is under challenge all of the time. We've got to where we have through the internet and the web as it has been. It's no way guaranteed that that will be the web and the internet of the future. So we need to do our best to protect that and to keep building on top of that.
So future is the next point again, to say where these developments follow now. We have seen this, let's say, change now with here to the automotive industry, and automotive is also something in change also. If we would see the early 90s where there was data available somehow in the governmental caves, I would say. On the other hand, there was a time where people really started to recapture the data or capture the data because it was much quicker. All the discussions, negotiations took too long or were even very difficult. And now I think we've done a lot of things now, or you have done a lot of things really, and to bring us to this state today. On the other hand, what are the challenges now in the future? If we think about and the discussion about this automotive industry is something, what kind of degree of data we would need, or is it more that we start to move from static data much more to dynamic one? And later on also, Philipp will give a complete talk. Maybe what call you the probes? Is that a good term for this? The new gold.
Yeah, so I totally agree with that, right? So in the past it was really like to know like where your house is and things like that. So that was really the big first barrier which enabled a lot of services. But the next level is really not to know where your house is, but it's exactly to know what is where at this exact moment. Where is there a parking spot that's available right now at that minute, and not where there's parking spots. And where there's traffic and where there's no traffic. And what is like the best route to take to somewhere. And where there are people, which are the bars right now, there are people at the moment so that it's worth to go to. And where there's all the cool events. So I think like really, with this explosion of data that we have, it really goes from like static to dynamic data. And I think this is really when like the next big explosion of services will happen. Because I mean, one thing that we have to see is that all this geodata is really radically transforming our society. In the past, it was like making you navigate a little bit better. But in the future, if you think about things like self-driving cars and like complete changes to the transportation industries, if you take together like the delivery drones and so on that you have in trials right now, all of them are really radically going to change where we live. Because if I can hop in the morning like in a self-driving car that can take me in an hour to my office, if I can work in that car, then I don't really perceive that as like traditional commute time when I drive. So, and like, this is, I think, really the next big thing, that it'll be a transformation which will be really much, much bigger than anything we've seen so far. And that's what's really the exciting stuff. And that's all enabled by dynamic data, because for this kind of stuff, you need to know exactly which way you can go at exactly at this moment.
Or do you see these developments, let's say also maybe from a free perspective, from free data? One of the things is how to share this data, for instance. Or is it the dynamic part something different than the more static part, which you reflected, for instance, in the OpenStreetMap world at the beginning?
So as far as the future goes, there's sort of two things that I find very interesting. The first is maps are disappearing in the same way that spell check did, right? So spell check used to be a paid feature, and then it was just part of Microsoft Word, and now it's in every text box that you use in your phone. And it became this sort of just background noise, became something that's just part of the environment. And maps are going the same way, right? People used to pay for maps, and now maps are just a part of your phone. And increasingly, they're part of every application, and they're just part of the device itself. Even if a map isn't being shown to you, there's a bunch of geography stuff that's happening in the back end. And it's really interesting to think where that's going to go. Like, if you open your phone and you want to find a pizza place, there's like 10 ways you could do this, right? I can go search Google, I can use Yelp, I can use the Maps application. And why are there these 10 ways of using it? And why don't these things all talk to each other, right? Why isn't my contacts list much smarter? So I think there's a bunch of integration work that's going to happen relatively quickly to both narrow down your options as a consumer to make this simpler, but also widen out where maps are available in every application. So that's the first thing. The second thing is with automotive navigation and self-driving cars. I think it's really hard to predict the future. I think there's really fundamental economic changes that are going to happen. Like, I own 2 cars, and if I buy a self-driving car, why would I buy 2? It makes no sense. So the market's at least going to drop by half, is my bet, and I'm willing to make an actual financial bet if anyone's willing to be my counterparty. But there's also reasonable arguments to say it's going to drop by 10 to 1 or 100 to 1, because why have a car at all, right? Why don't, if Pizza Hut will send me a car and I can go do all my errands as long as I stop at Pizza Hut on the way, right? Those kinds of economic changes are coming, and it reminds me a little bit of when desktop publishing happened with the Macintosh in the 80s, that the very first iteration was to sort of try everything, put 50 different fonts on a piece of paper and see what would happen. And that's kind of how we're looking at self-driving cars today. It's like we're viewing them as like, I have a BMW 7 Series today, I'm going to have a self-driving BMW 7 Series tomorrow, right? But really, the fundamental problem is, how do I get about, not what type of car do I buy? And when you look at it from that lens, there's all kinds of interesting things that could happen. So I find it very hard to predict. I mean, I'd love to be able to take $1,000 and put it into General Motors or to Toyota or to some other company and predict that they have the answer. But I think, despite all my ideas, these are just ideas. And my problem is that I can't predict what's going to happen, which, by the way, makes it very interesting.
That's very often. In 2004, you invited me once to the Cambridge conference, and there was a guy from UK Telecom, was a futurologist, and they have a 30, 40, 50 years prediction time on the one hand side, but also they have an experience of 40 to 60s, I think, and they said about 50% of the things which were assumed in the 60s something arrived. 50 others not, but 50% is not so bad really in that sense. But how do you see the development here? Because I think it's very interesting to hear what happened 2015, and it's also very close now here.
Yeah, so first of all, we have not been yet sold, so we're in the midst between being sold and being acquired. So if you look at the current Nokia annual or quarterly statement, we're classified a discontinued business, so we're making a lot of jokes about this. But this is just from a financial reporting perspective. No, I think what we'll see going forward is a disruption. And what happens in a disruption is very hard to predict. This is why I agree, I would also do some bets, but it's very hard how the whole thing plays out. And in particular, it's a little bit also like gold rush. There are a few terms that everybody jumps to, autonomous and connected car. The other gold rush is IoT and smart cities, all big words. But I think they all have one fundamental thing in common. Without location, these things will not work. So location is an absolute mandatory prerequisite to make it work. And I think whereas in the past you could say location and mapping was a useful utility, but to be honest, you could live without it. I think we all, 20 years ago, lived without it. We had paper maps, there was a phone book, we called friends and asked for recommendation. In the future, we will see that certain things to organize our way will not work without. Living in a city with a population of several million, fighting, environmental disasters, having sustainability, organizing our life will not be possible if we not enable them in a clever way. And this is where all the data flow that comes from multiple sensors, phones, cars, traffic lights, energy meters, street lights, and God, what have you, all will play a major role. How it plays out, we don't know. But I think we'll see, my prediction is to see that every piece of information that is being transferred to the net, to devices, to cars, today has already a timestamp, and that's accepted. I think we'll see that every little piece of information will have a location stamp in the future. And this opens up the game to do all the crazy new things that hopefully you spend a lot about thinking about, because this is what we need. We need the innovation to provide the solutions to these fundamental questions.
Future and or how things develop could be something which has a time where it's, let's say, in a lab state, a long time, and suddenly in a short period it would expand in society. A lot of technology, if technology is there, it doesn't mean that it's being adopted. Because of some reasons, because maybe society is not ready for, has not finished the other cycle. I was in 2009 in Mountain View on an OGC conference. I looked out of the window in between, and there was a car driving all the time around. A car driving all the time around. So when the break, I go there and I ask there, and they all speak German there. Oh, from where are you from? I'm from Stuttgart. I said, I was studying Stuttgart Aerospace. That's interesting. And so it was a bit early where things already started, but I think it's also very interesting to see that there are players which came from IT, which can have the power also to revolutionize traditional, old-fashioned, don't know, but traditional players in a sense. And I think this could be very, very exciting.
Thanks, Roland. You were not meant to mention that. That was meant to be secret, but obviously at the time. That was 2009. I think actually everyone has said something that's really important, that's really fundamental, in that this technology is really going to start to change society much more fundamentally than it has done up until now. You know, yes, we could probably all still survive if we didn't have maps on our phones, and we can get by. Although, you know, having maps on our phones has made life much easier for all of us. But now this technology is reaching a point where it is impacting on economics, is impacting on society. You know, fundamentally, I think, right, you know, if we live in a world of autonomous vehicles where we no longer own them, they appear on demand, they take us in the most efficient way between A and B, that fundamentally changes the landscape of cities. You know, why would you build car parks if you don't own cars anymore? Why would you invest on large public transport systems if actually point-to-point navigation delivered by autonomous vehicles is much more efficient? And what about the energy distribution model then? Powering electrical cars, is it done centrally? Do you have fuel cells? It suddenly becomes, you know, a much bigger issue that our technology is part of. And at that point, we run up against that issue where technology hits barriers because you're actually now impacting on vested interests, or you're impacting on policy drivers. And you're beginning to see this with, you know, the impact that Uber has had in Europe, where from a user's perspective, something like Uber is brilliant. You know, I can get a taxi just when I need it, and it'll take me to where I want to go. And it's driven primarily by being a very efficient way of doing things, by getting, you know, the taxi that's closest to you to the destination you want to go to. It just works very well. But it impacts up against traditional ways of operating and managing and licensing taxis. And I think we're going to start increasingly having our technology banging up against societal norms, societal ways of working, where we just have to kind of work through that process. You know, if we're going to build smart cities where we need to be able to share much more about our energy use, how do we make sure that that energy use data is shared to the people that we want to make it shared to? Do we want to share with our energy supplier? Do we want to share that data with a third party? How do you manage those processes? Another element I think that is obvious if you think about it, and is a different way of working to what we've done historically, is that much of these new technologies, these new opportunities, are driven from the ground up, from the bottom up. They are by their nature a distributed way of working. And again, that often impacts on the more traditional top-down way of planning economically and planning society, where you have, you know, a central organization that manages and controls access to resources or accesses to information. The way the web works is the absolute opposite of that. It's distributed by its very nature, and therefore harder to manage and harder to control, but in many ways more efficient. So I think, you know, increasingly we will be delivering technology that will have these much bigger impacts on society, and we will end up actually having more challenges that are around policy and around you know, the societal impact of the technology than the actual underlying technology itself. You know, many of the technology challenges that we will face, we will probably solve relatively easily. The impact of those technologies is going to be a harder thing to manage.
So now I will ask also one question again, but then if you have another question, I think there are also quite a lot of things. Prepare one. I can give this microphone to you later on. Now we are also in the university, looking a bit back when you started, came into university, looking back, there are also some students. We can show some students where they are. And, you know, I have multiple hats, but we are here also, and sometimes I tell them, yes, it would be a good idea if you could do some programming, for instance. And they say, no, I want to solve the big questions of the world. So I would like also, and they said, yes, but a bit programming is not bad because you can show some things what you can do. If you would look with your experiences now, and if you look back, what are requirements, skills, or requirements maybe also university should teach or give? Because there's a change sometimes. There are some 100 years ago, different technology, mechanics would be very good. Then later, electronic, very good. But there's a change of the required skills. What do you think? What should the universities, for instance, change or adopt or correspond? Even though they are sometimes very lazy or very late in adopting these ideas. It could be 100 years.
Yeah, I think one thing that universities can do is to make the people actually do something that practically matters. So I think what we see in some universities is that they make people contribute to open source technologies, right? So that's why a lot of people in universities, they contribute to OpenStreetMap, they develop open source projects around that. So I think that's the number one thing, because basically you learn stuff by putting it out there, right? I mean, same as Steve explained, like he just hacked around. I mean, he didn't come with this 20-year vision, what it's going to be. He just started to fiddle around. And I think you only get that feedback if you put it in the real world. So I think what I would encourage universities is to not do stuff which is academically very challenging and very interesting, write very interesting papers, but maybe actually build a piece of technology, put it out there as open source and see what happens.
So I'm going to take a slightly different tack. I think, so what would I tell myself as a student? How about that, right? 10 years ago, is that okay?
What would you tell our students today when your experiences?
But that question I have to take responsibility for. Right? I wish I'd been more contrarian. Just by being contrarian in its very nature means that you're going to have less competition in the things that you do. If you do the same things as everybody else, it means there's more competition, which means there's less stuff for you to do. And I'd always work at the boundaries, right? Don't be afraid of dropping out, sorry. I dropped out of physics and I dropped out of computer science, and they were both very fun. But being able to work at the boundaries of the two things where physics and computer science intersect, and along with where those things like computer science and mapping, where they intersect, is very interesting. But if you stay in either discipline, if you stay in computer science, it gets theoretical very quickly. And if you stay in mapping, very similar, you end up in GIS. But if you find the intersection between things, both there's fewer people and it's more interesting because you bring something unique, right? You bring a new way of looking at problems. So keep looking around, is what I'd say.
Your perspective?
Well, yeah, it's a difficult question. I think university are primarily about knowledge, right, and wisdom, and providing this knowledge and wisdom to people. But I think there's often, an attitude to have the absolute. I mean, the truth, right, what it is. It's a formula, or it's a law of nature, or whatever. I think what we'll see also going forward, the revolution based on data, a lot is about experience, combining things in a clever way, and do it quick and fail fast, because the way is not predictable. So it would be great if university would be more supporting students and teachers and bodies just to try things out. Identify a problem, try things. Just on the way, how to solve a problem, you will learn much more than trying to find the ultimate answer to those things. So it's really about the way, it's not necessarily about the results. So this will be something I can encourage. And if some of you, like Steve, pursue an entrepreneurial career, I can fully support Steve. But you need to find a problem that you solve, and hopefully many people consider it as a problem, because then potentially you could make a business out of it. And this could define your success.
And that one, sorry.
I guess I'm also maybe a bit contrarian on this, and I think when you're a student, it is your opportunity to really dig deeply into a subject that you love, that you're interested in, and actually if it's not that practical, it's not that relevant, that's okay, because actually it's probably going to be the one opportunity you get that you can dig really deeply and study something that may be quite arcane and actually may not have a practical impact. But the experience part, I think, is what's really valuable, is being part of a community of fellows who are interested in learning and new experiences. And if there was one thing that maybe I'd get the universities to change, would be to be a bit more cross-discipline, as Steve says, where the intersection between things happen is really interesting. But try to broaden that intersection to be between arts and sciences, and to just take that opportunity to sit in the canteen and refectory and talk to economists, historians, physicists, medical students, because actually when you get to work, you won't be working with a bunch of other geographers or a bunch of other physicists or a bunch of other computer scientists. It will be a much broader range of disciplines. And that's actually where the excitement comes. You know, lots of people on the teams I work with are not computer scientists. You know, a lot of, one of the most fun guys I work with is an art historian. And you know, he brings a completely different perspective to what we do, and that different perspective is really valuable. And it's those different perspectives that I think universities have great potential in fostering if we can kind of break down those internal departmental barriers. And I know, because I was an academic early on in my career, you know, academic department barriers are the hardest things to break, really difficult.
So, I think we had a good starting point now, and maybe there are also good questions around the floor. Maybe first of you, give you maybe just your name. Also, if you can direct the question to who would be the right person to answer. Also, you can say how to point it. So, who has a point? So early? There is one? Come around.
Hey, good morning. My name is Felix. I want to get back to the question of the importance of the dynamics in geodata in the future. I think we probably all agree that geodata is becoming more and more real time, and that's really important. Now, when you look back at static data, I think that OpenStreetMap has proven in a very impressive way that an open model can compete with proprietary models. So the OpenStreetMap is a very good competitor to proprietary maps. But how is that going to be for the dynamic data in the future? So if I look at the landscape today, it seems like dynamic geodata is still very much in the hands of proprietary organizations. So I'm wondering whether there will be a chance to also have an open platform for dynamic geodata like we have it for static geodata today.
Anybody you have to ask?
Obvious.
But also, you had also one. I think it's first for Philipp, but you have also some ideas about the legal point from
Thought I could get out of it. I have to solve this one? Yeah, okay. I think it's really interesting. I think OpenStreetMap proved a bunch of things, and I think it's an interesting model. But OpenStreetMap was started in a time that is gone, right? And I thought that OpenStreetMap had the best model because the cost of integration, the cost of building the thing was zero, right? If you're using volunteers, it's zero, which is really great because if you imagine the efficiency of something as something divided by the cost of producing it. If the cost of producing it is zero, it means you're infinitely efficient at creating something, right? Like you can't beat that. But it turns out, there's other clever people in the world that are making maps much cheaper today as well, right? So it used to be that there were only 2 big maps in the world, then OSM came along, Waze came along, now there are 4, right? But if you have self-driving cars like your Waze and you've got, you're like Tesla, and you have people buying these cars and driving them around that are creating a map for you, they're also creating a map for zero cost, right? They're getting that GPS data for free. They're most likely, I don't know that they are, but if I was them, I'd be getting all that imagery for free, right? Because they've got cameras on the cars. So what do you do in a world where the cost of production is now zero, not just for OpenStreetMap, but for a lot of people, right? Or it's approximately zero if you're the size of Google or Microsoft or Apple or something like this. So I think it's definitely a problem to be solved. I definitely think that open source has a role to play and something to contribute. But I wouldn't think in terms of merely copying OpenStreetMap, right? But taking the things that worked well there and then marrying them with the world that we have today, right? When my watch is a computer, when every car is collecting imagery, it changes the dynamic slightly from building something when you're relying on volunteers and trying to convince people to go out and do something for free, that part of OpenStreetMap is probably gone, right? Because the cost of production is now zero. But that doesn't mean that an open platform doesn't make sense, right? And integrating other sources of data and having similar sets of incentives, but without that crowd, or a different sort of crowd, I should say. And it's important because you never want to sort of just take your model and just sort of make it slightly different for the future, because the future is fundamentally different. I hope that was useful. Was that useful? Good.
I think in terms of the open platform for dynamic data, the key issue at that moment is cost, because if you want to like take in sensor data from millions of cars or phones or whatever, then basically the server infrastructure which you need is a lot. And that's like one thing that like an open source model still struggles with. And I think that'll be solved over time as computation gets cheaper, because we were thinking exactly about the same thing. Why not just like put up an open database where like a couple of geeks can just put in like a couple of libraries in their phone and they just send all their movement data to it. And then maybe somebody can do something useful like predicting traffic or predicting people movement. But the big problem is if you want to do this in an open fashion and then millions of people send their sensor data, which you really need in order for it to be useful, then you have a quite big operation cost, right? I mean, you can build up a OpenStreetMap database with on a 5,000 euro server, on a rented $100 a month server. So that's like what some individual can support. If you want to have like all this dynamic data, then you talk about like 100 or 1,000 times more data. And if you think about like what a LiDAR equipped car is producing like gigabytes of data per hour, and if you multiply this by 1 million cars, then you look about like millions and millions of backend operation costs. So I think we're really thinking about it. I don't really have a good solution to that, because I mean, that's exactly what we wanted to do, is that why can't we make like an open backend for dynamic data? And right now, really the only inhibitor is not technology. The only inhibitor right now really is the cost to operating that, because somebody needs to be willing to pay the bill. But I think this is maybe to some of the car companies now that they may be willing to foot the bill for something like that.
First, we're not a car company, and I hope we never will. We maybe own and have investors that are car companies. But I think it's a very important point, and I want to re-emphasize this. There is no free. I think we're living in a world where a lot of investments have been made, and you can look at it. We spend every year roughly between 800 and 900 million in cost to, make maps and distribute maps and compute services and others. Whereas, 5 years ago, our internal cost, there was no cloud hosting costs. We didn't need to budget. We had a few databases, and this was a few 100,000 per year done. Now we have substantial cost in cloud computing. And these are the costs that need to be paid. And exactly, if we see the data revolution, I mean, if we just start to compute what amount of data could flow, bandwidth need to be paid by somebody, operator networks. So somebody pays for that and wants to recover some of the costs. So this is why the disruption is about the whole value chain, but we are moving to an age where it's all about computation of vast amounts of data, and the outcome may be a map, right? Or it's maybe something we call sometimes a dark map, because it's machine readable so that a car can drive autonomously. So there will be many, many flavors of that, but it needs to be financed. So the same way that and I think we'll move to that where data will be available to innovate, it needs to be in a model where the cost can be covered and businesses can exist, because otherwise it will not. And I just want to make another point. Probably the biggest, from my perspective, the biggest event that kicked really the location industry big time was a billions of dollar investment done by the US government called GPS, and make this available to the public for free. But it was paid by taxpayers of the United States, sending up the satellite, and was for military use. And first Reagan and then Clinton gave it free to the public. But somebody paid for that. All of us paid for that, or not. Probably us, the American citizens, paid for that by the tax bill, and we will by Galileo. We pay in various ways. So I think free sounds good, but if you look in reality, there's huge investments need to be done. There are companies willing to do the invest, but companies are there to make a living, to make a profit. So we need to find a proper way how the whole value chain can work, that this exists. Only then we'll come to a model where data is available, free of a very low cost, to create innovation. And this is clearly something we, and as our new investors in Owner Express, is something we aspire as well.
I agree. I think where we saw the great growth of open geodata, around, OpenStreetMap and the general sort of open source movement around that was relevant at a point in time for a particular problem. It was achievable, as Steve pointed out, to get a group of enthusiastic volunteers together and a relatively cheap and simple server architecture and deployment to be able to create a street map, a static street map, in effect. Doing that in real time is much more complex. The requirements in terms of networking infrastructure, in terms of managing the latency of that infrastructure is more complex. You also have different types of real-time data as well. You have the crowdsourced content that is very valuable, being able to tell you, the average speed on a particular section of road. But there's also the data that comes from canonical sources, so information about how a public transport system is operating. And you want that from the source. You want that from the Berlin Transit Agency or Transport for London, and you want those feeds to be real time as well. They are, by their very nature, expensive. And then when you get to thinking about things like autonomous vehicles, I think we underplay just how complex and how computationally expensive actually managing a fleet of autonomous vehicles is going to be. The volumes of data, the computational resources you're going to have on every individual vehicle and their networking, it's not something that is ever going to be achievable using open technology for many, many decades, because it's going to be so capitally intensive. And the business models around actually building that from a commercial point of view are still questionable. It's going to be incredibly expensive, incredibly complex. So, I think sometimes we underestimate, because of, the experience we've had so far and the success we've had so far in the open model, where we can take it in the future. But, for what I can see, the next 10 or 20 years, the leap in technology requirements is just going to be extreme. It's like almost another moonshot, the amount of capital that's going to have to be invested to deliver some of these capabilities. Multiple times, yeah.
Another point is what I think now, sometimes they call it post-Snowden effect. It was a long time this data, we knew it was collected. It was a bit difficult for a lot of customers to understand or to accept that it's done. But we know that today some other people also collect this data, and in a much different scale. On the other hand, it's also now, because it's known that it is, we can start to use it, also for personal usage. And it's very interesting to see suddenly that this kind of data is in that way available, that a museum you can see today with a Google service how many people arrive when. That's great. I really like this. So there are some developments on the one hand side which are technically driven, commercially is one thing, but also legally, from a legally point of view. And I think this is done now. So the idea really to use this kind of probe spatter is something which is now possible, because we know that we have to think different. And a bit of funny story was with this prisoner. There was a prisoner in Aachen, I think he was a long time in prison, and the first thing when he made it to break out, he robbed a mobile phone and said, now he's got to talk. And of course the guy who being robbed already reported it to the police, and the prisoner was not aware about this. You know what's happening now. The police just saw him on the map, and they just waited on a little street somewhere outside the city with no people when they grabbed him. And he suddenly was shocked. He said, why? He was a professional guy. He was really very good in his activities. He was not aware about these things. But we are now all aware. We have to adopt this. And this is why we can start also use this in this post-Snowden area much more about location. This is something. We have time for another question or another point. Who has a point?
Hello, my name is Oleg from Navigon. So I got a question for all presenters. So basically it's the question regarding your vision about interlocation services, because it's definitely a big hype for last 3 to 4 years regarding this interlocation services, but still it's not a lot of cases which proved business model. And but of course now it's 80% of navigation requests which are coming from indoor. And of course, it's a big problem. So what do you think about this?
I agree, it is a big problem. I think it's one of those areas where there's no obvious silver bullet technology that everyone's going to run to. There are various technologies to basically solve the two problems. One is to be able to identify whereabouts you are when you're inside, when you don't have reliable GNSS signals. So what other technology can you use to determine your location? And then the other problem that I think people kind of underplay as well, but actually in many ways it's going to be the harder one, is how do you map indoors? Because it's a more complex environment than mapping outside, both from a technological point of view, but also from a legal point of view, because most indoors are private spaces that you need the permission of whoever owns, operates that building to map and to make that information available. So what I think we'll probably end up doing is maybe taking a slightly different approach to the way that we map outside and have things that are much more, as I mentioned earlier, much more about that kind of very egocentric mapping of what's around me, what am I interacting with. I might not have a topographic representation of the building, but I'll know where I am in relation to the coffee machine, to the elevator, to the laser printer that I'm using. And it's those relationships that are topological, not topographic, that are important to me. And that may allow me to deliver services without the requirement of having a complex 3D data model of every building that I might want to navigate through. But to be honest, I don't think anyone has really got the solution to this, and everyone, I'm sure everyone here, is spending a lot of time and effort trying to solve these problems. Because as you rightly say, we spend most of our time indoors, interacting with stuff that's around us, and there's lots of opportunity in that space.
Yeah, I would also like to point out making a business out of location is very, very difficult, to be very honest. And we're in it, and it's a tough business because there's a lot of competition, and there's a lot of players like one from my former participant here, who's not in the business of location, but invests a lot into location to make a business in search and many, many other things. So making a business out of location is very, very difficult. Particularly when you need to have a use case that value is created and you can monetize. And for example, car and door-to-door navigation is a use case that is monetizable. But with indoor mapping, it starts to get already difficult. There's a lot of investments to be made in mapping, in potentially technology infrastructure that you have meter precise indoor positioning, and we have this technology, but who pays for this? Who pays for the infrastructure to put into place? Who pays for the mapping? Who is willing or who has a good compelling business case to make all these investment possible? I think we all think about local commerce, maybe it's more safety related issues, so many things. But I tell you, being in the location industry, making money out of location is very, very hard business to do. So again, I think much more promising, and this is where many, many businesses are very successful, is if you do a business that uses location and maybe relies on location, but solves a problem that combines multiple other things. So that's my advice. Look into those things, and then they will need location. They're willing to invest and pay potentially for infrastructure, for map data, or for other enablers, cloud, compute time, storage, and so on and so forth to make that possible. And the vision is, again, I think we're still not there where location is ubiquitous. Where wherever you look in your watch, in your mobile phone, automatically without powering up, you know where you are. Everything is integrated. Your next meeting is whatever, 20 minutes away, and you should not take the taxi or what I did this morning, so I came rather late. I should have taken my bike or the public transportation. So we're still far away. We're not there yet. Still a lot of things to solve, but I'm pretty confident that they will be solved because they make sense to be solved.
I agree. The thing that makes me, I agree with everything that's been said. The thing that makes me think about is that GDP is a pretty poor measure of economic output, but it's the best one we got, in aggregate. And electricity took about 100 years to show up in GDP, and computers still have not shown up in GDP. So you have these things which create vast efficiencies, right? Computers all the way back from the 80s or 70s, pick a date, have not shown up in GDP yet in the same way that sort of airlines have never made money. And it's hard, you know, you create all this efficiency, but really you're creating a lot of churn, right? Like I think of the phrase of faxing my travel agent, right? There's all these things that no longer exist because of computers, but the value is just shifted around, right? And so if you skip forward to new innovations like indoor mapping, when will that show up in GDP? I don't know, but if you go to San Francisco, which is, you know, the leading edge of all of this stuff, you go to most of these big buildings, they basically pay a guy to take you around, right? I don't know, so that costs you $100,000 a year in your building and you're charging millions of dollars. So it's a relatively small amount of cost to solve the same problem, right? That particular problem, I like Ender's Game, right? If anyone's read that book or seen the movie, there's these lines appear on the wall to tell you where to go and you just have to follow the blue line or the red line or whatever it is. How we solve it, I don't know. I really hope we sidestep it somehow. The other nice thing about GDP is that GDP used to double every 10,000 years, then every 1,000, and now GDP is doubling every 100 or so, I think, if I remember. It's due to go to 10 years, so we're due to start doubling GDP every decade and then every year. And it's very interesting to think about how we get there. And it's all going to happen very quickly. That's the other thing. Far more quickly. You know, Ed mentioned 20 years for driverless cars, or 10 or 20 years. I think that's reasonable, but it could be a lot quicker. There's a bunch of things coming. If you go read The Singularity is Near, I don't want to fight anyone over that book, but there's a bunch of curves that are happening, including GDP doubling, where it gets really hard to predict what's going to happen. So it might be 20 years, but if you think what the world looked 20 years ago, I mean, it's radically different to where it is today. I mean, you had faxes and travel agents, for example. So again, hard to predict.
Okay, so that's very hard, coming back to indoor mapping after GDP and the singularity discussions. So, I'll take it back to a little bit more the practical part, although I definitely agree with Steve. So I think for indoor mapping, a couple of things need to happen. So first of all, indoor mapping is fundamentally different because the question is all like navigation always starts with a search, right? And indoor, the point is like you don't necessarily search a shop. I mean, it's not that exciting to say like, okay, show me like indoor, like how to, like in a big mall, how to get to this specific shop. So that's not so exciting. I mean, that's not that big use case because that's already quite well solved. But then the question is like, if you're like in a shop and say like, okay, I'm in a big mall and I want to buy like a specific towels and that's all of them which are on offer and that's the navigation. So that's kind of the next level of data. So I think what is required is like, as Ed says, you need to have like a technology to indoor locate you very precisely. So you need to have something like iBeacons or so on. So that's the first step. Then you need to have a technology to produce map at a reasonable cheap level. So you need to have like the sensors in your phones, which like some LiDAR sensors or something like that you can automatically map those indoor spaces in a reasonably cost-efficient way. And then third, you need to have the data where you want to go. And that, in my opinion, like in indoor is often like the products or the things that are on sale or like meeting rooms. So you need to have really this precise data that's lacking. And I think I would prognose that it'll definitely take like a few more years until like the first two problems are like kind of on the way to be technically solved. They just need to like follow like getting cheaper, right? I mean, because we have the iBeacon technologies, we have the LiDAR technology for phones. So that's probably another like 3 to 5 years until it gets reasonably cheap. And then you need to have like the businesses also, as Christof said, that have the data, that have an interest to use it. So I think I would say like we're like somewhere like maybe 5 years away from like having the opportunity to use something like that at scale, hopefully. But as Steve said, it's very hard to predict the future, so it might take 10 years as well.
Yeah, thanks very much. I think it was a good starting point this morning. Lots of points, starting thoughts, future backwards. I would say thanks for coming here, isn't it? So we're going now for the first break. But those who start interested in the skiers and the wearables, this is Jonas, and go to him to meet him for the hackathon, which is will run on Saturday, and win. What was it? 2,000, 1,000, or the other one. So these people who are interested in this, approach Jonas in the break or later on, or anytime, I would say. Good. So have a break now.